Hello everyone, my name is Rupak Kumar Das and I am a MS student in computer science at University of Minnesota Duluth, and my research advisor Dr. Ayong Lee is an assistant professor in computer science at Kennesaw State University. Our paper ID is 14 and it is titled as a study of load balancing solution of mobile cloud computing for next generation mobile applications. So, what is cloud computing? Cloud computing is the on-demand availability of computer system resources, especially data storage and computing power, without direct active management by the user. It allows its user to have access into hardware parts as well as software parts at any time from any place. Some examples of cloud services are Amazon Elastic Compute Cloud or EC2, Google App Engine, Windows Azure, Apple iCloud, etc. Here we can see a cloud computing architecture. So, what are the types of cloud? Based on common deployment model, we can classify clouds as below. First of all, public cloud. It is managed by third parties which provide cloud services over the internet to public. Private cloud. It works on a private infrastructure and provides the user with the dynamic provisioning of computing resources. Hybrid cloud. It is heterogeneous distributed system resulted by combining facilities of public cloud and private cloud. And finally, community cloud, which is a distributed system created by integrating the services of different clouds to address the specific needs of an industry, a community, or a business sector. So, what is mobile computing? Mobile cloud computing is defined as an integration of cloud computing technology with mobile devices to make the mobile devices more resourceful in terms of computational power, memory, storage, energy, and context awareness. Mobile devices has limited computational capability, storage, and power capacity. Due to size constraint, it may not possible to get unlimited storage and computation capability in mobile devices. But it is possible to store information and compute different processes in remote servers using mobile devices. Here we can see the connectivity of mobile devices with cloud. So what are the advantages of mobile cloud computing? Mobile cloud computing supports multiple types of platform. Real-time data availability is possible using it. It is very much cost efficient, it's very accessible and flexible, and data recovery is possible with mobile cloud computing. So what are the challenges of mobile cloud computing? Security and privacy issue is the most challenging part of it. It also needs stable connectivity for its performance. The latency shouldn't be that much higher. It must ensure the elasticity and scalability. And bandwidth limitation is another challenge in case of mobile cloud computing. So, what is load balancing in mobile cloud computing? Load balancing refers to the process of distributing a set of tasks over a set of resources with the aim of making their overall performance and processing more efficient. Commonly, there are two types of load balancing algorithm: static load balancing algorithm and dynamic load balancing algorithm. So, static load balancing algorithm is used when the variation of load is low. The decision of load shifting does not depend on the present condition of the system. Some examples of static load balancing algorithm are round robin, max min, min min, etc. Dynamic load balancing algorithm. It is used in case of real-time analysis. Processes can be migrated from one server to another server in real time. Some examples of dynamic algorithms are ant colony optimization, honeybee foraging, active clustering, etc. So what is the importance of load balancing algorithm? Why we need load balancing algorithm in case of cloud computing? So efficient uses of resources can be ensured by a efficient load balancing algorithm, and it prevents from getting overloaded and possibly breakdown. It improves service availability. It is required to prevent the downtime of the service, and real-time analysis can be achieved by using an efficient load balancing algorithm. So Network Simulator 3, we used Network Simulator 3 for our research purpose. Network Simulator 3 is a discrete event network simulator mainly for research and educational purposes. It is an open source simulator software for networking research. The NST simulation course supports research on both IP and non-IP based networks. It supports both C++ and Python programming languages. So here it is our research methodology. Our main objective of this research is to demonstrate a topology without any load balancing algorithm and with a static load balancing scenario using Network Simulator 3. This will give us an idea of importance of having dynamic load balancing algorithm in our cloud computing architecture. Both link load balancing and server load balancing scenarios are considered here. So here is the experimental setup. We have used 7 clients in both cases. We have used 1 server in case of link load balancing and 2 server for server load balancing. The packet size is 1024 byte. The packet interval is 1 second. The link data rate is 50 kbps. The link delay is 1 millisecond. So there are our simulation topologies. The first two are link-based topology without and with load balancing. The third and fourth are server-based topology with and without load balancing. So our results. In case of link load balancing, the end-to-end delay of the simulation is much higher in single link simulation topology than the multi-link simulation topology. In case of single link solution, all the packets are transmitted through one link, which requires much more time as the link bandwidth is equal for both cases. On the other hand, in case of multi-link solution, packets are transmitted towards server through 2 links, so the whole load is distributed between those 2 links, and this requires much less time. In the server load balancing, the end-to-end delay is much higher in single server solution than the multi-server solution. This is because in case of single server scenario, all packets transmit to the single server. That single server receives all the requests from the nodes and sends corresponding requests. As all the requests are being handled by one single server, the end-to-end delay is higher in this case. On the other hand, in case of multi-server scenario, requests are being distributed among 2 servers. So each server handles half time of requests than single server scenario. So the end-to-end delay is lower in this case. For the same reason, we can see that packet receive ratio is lower in case of single link simulation topology than multi-link simulation topology, and it's also lower in single server solution than multi-server solution. Throughput tells how much data is transferred from a source at any given time. In this experiment, total number of packets sent is equal in both cases, but due to the low end-to-end delay, throughput is higher in multi-link scenario. In contrast, the throughput is lower in single link scenario. And in case of server-based topology, the result is similar. As load is distributed between 2 servers, the throughput is higher in multi-server scenario than the single server scenario. So conclusion, in this research, we describe the architecture of mobile cloud computing and the importance of it along with the necessity of load balancing in a network. With the implementation of an effective dynamic load balancing algorithm, the throughput and packet receive ratio increase more significantly. It also reduces the end-to-end delay of the system. In our future research, we are interested to implement a dynamic load balancing algorithm inside the load balancer, which will dynamically allocate load based on the incoming server request.